if you have n different objects, there are n CR ways to select our objects from these n objects. For example, if we choose two numbers from 1, 2, 3, 4, and 5, then we have 5C2, that is 10 ways to choose the numbers. Here we have the 10 ways to choose the two numbers. Note that we don't have the case 2, 1 because 2, 1 is just equivalent to 1, 2. We don't have 3, 1, that is 1, 3, and 3, 2, that is 2, 3. And there is no 4, 1, 4, 2, and 4, 3 because they are already considered in previous cases. But how do we know that the number of ways to choose the numbers is 5C2? By definition, 5C2 is equals to 5 factorial divided by the product of 2 factorial and 3 factorial. I'm going to explain why do we have 5 factorial, 2 factorial, and 3 factorial in this calculation. Here we have the 120, that is 5 factorial ways to arrange the 5 integers 1, 2, 3, 4, and 5. Now we focus only the first two numbers in each of the 120 arrangements. Say in these 6 arrangements, the first two numbers are 1 and 2, and in these 6 arrangements, the first two numbers are 2 and 1. If we don't mind the order of these two numbers, then for these 12 arrangements, we have 1 and 2 as the first two numbers. Now I'm going to find arrangement that begins with 3 and 5. Begins with 3 and 5. This is the 6 arrangements. Begins with 3 followed by 5. And then we have 6 more arrangements that begins with 5 and followed by 3. We can see that for each combination of two numbers, there are 12 arrangements among these 120 arrangements that begins with that combination. And we have 120 divided by 12 is 10. That's why we have 10 combinations to choose two numbers. But where does this number 12 come from? This 12 is equals to 2 times 6. Take this 3, 5 case as an example. There are two possible ways to start an arrangement with 3 and 5. That is to start with 3 and followed by 5, or to start with 5 and followed by 3. We have such two ways because the factorial of 2 is equals to 2. Once we fix the first two numbers in arrangements, there are still 3 numbers left, and these 3 numbers has 3 factorial, that is 6 ways to arrange them. For example, in this 6th case, we have the remaining 3 numbers 1, 2, and 4, 1, 2, and 4, and there are totally 3 factorial, that is 6 ways to arrange them. So there are totally 6 times 2, that is 12 arrangements, that the two beginnings numbers are 3 and 5. These 3, 5 pairs is just an example. For any combinations of two numbers, we still have 12 ways of arrangements, that is corresponding to these pairs of numbers, maybe 1 or 2 or maybe 3 or 4, any pairs. So the total number of combinations is 120 divided by 12, or that is 5 factorial divided by the products of 2 factorial and 3 factorial, that is 5C2. Now I put the 120 arrangements into 10 groups. In each group, there are 12 different arrangements. Look that in a group of arrangements, we always have the same combinations of the first two numbers.